Hi friends, welcome to TechieMit. So in continuation of the multi-threading related series, I am going to bring you a new video on Reentrant lock in Java. So what do you mean by Reentrant lock in Java? So let's see with the help of PPT. Let's dive deep into the video. So first to start with, the Reentrant lock is something that as per the name suggests, re-entrant into the critical region or critical section. As in the synchronization, it's in contrast. If you see in the synchronization, the concept was like that. Thread will start its execution, it will complete its entire execution, and only after then it would allow another thread to execute, and synchronously one after a thread after second thread after third thread after fourth thread. So in synchronous manner they would execute. So but over here the overhead of time is there, because in the critical section, or to access the critical region or the shared resource, only one thread is allowed, and it should complete all its execution. Means in its entire execution should be completely, all its activities it should be done. Only after then it will allow other thread to execute. So in contrast, new concept called the Re-Entrant lock was introduced. It basically provides extension. Now let's go to the definition. It basically provides an extension to the synchronization mechanism in which a thread is allowed to hold lock for an object or multiple items instead of conventional synchronization, in which the thread holds a lock and the other thread waits until the execution of complete thread is completed. So in Reentrant lock, thread is basically allowed to hold lock for an object multiple times instead of conventional synchronization. Means thread will hold a lock, it will hold the lock for some time, and it will again release the code. Again it will acquire the lock on the executed object. So meanwhile, when the lock is released, some other thread will also able to execute the critical exec. So it will concurrently help achieve concurrency and synchronization, and it will help in execution time, save the execution time, and increase the execution speed. So basically how it works, it implements a lock interface that provides more extensive locking operation that can be obtained using synchronized methods and statements. Yeah, so basically it implements a lock interface, and it contains a set of methods to that provides extensive locking operations that can be obtained using synchronized methods. So this was introduced to save the other threads for starvation in execution, also to speed, as I said. This was basically introduced to save the starvation starvation of the threads in execution, and speed up the execution. So basically a Re-Entrant lock is owned by the thread last successfully locking but not yet unlocking it. The thread invoking lock will return, successfully acquiring the lock when the lock is not owned by the thread, owned by another thread, as I told. Re-Entrant lock is owned by the thread last successfully locking. So like if a thread wants to held the lock on if thread wants to hold the lock for some time, it will be the owner of the lock. It means kind of it will be hold the key for locking it for some time, and also it will lock for some time, for some duration, say some milliseconds and so. So after that, after that duration of time, some other threads will definitely enter into the execution of the critical region and try to access the shared resource, and the thread invoking lock will return, successfully acquiring the lock when the lock is not owned by another thread. Method will return immediately if the current thread already owns the lock. So if there is a, now consider the scenario that there are multiple threads, and one thread is already holding the lock for an object, and if another thread tries to acquire the same lock, but so it will return back. So during the same duration, suppose 10 milliseconds, there is a thread T1, it holds the lock for 10 milliseconds, and within that 10 milliseconds, if another thread tries to acquire the lock, it will be not allowed. So here the simultaneous acquiring lock condition is also resolved. So synchronization is achieved, it means, but through re-entrant locks. So within, for that specific amount of time, only that thread would be executed, and the another thread would be allowed to execute, but after it, the original thread that acquires the lock has released the lock, and it will allow to access the shared resource. So method will return immediately if the current thread is locked. Yeah. So this can be checked by using isHeldByCurrentThread and getHoldCount. Yeah. So isHeldByCurrentThread, it will be a Boolean method, and it will check if the current lock is currently being held by any thread, and getHoldCount, and it will return the hold count of how many threads are waiting to be hold on it. Some important methods as we discuss. So as you know that it basically implements the lock interface. It contains the lock method. It increments the lock held count by 1 and assign the shared lock if it's available. And so lock method is there. Increments the lock count by held and assign the shared lock if yeah, as I told that if the thread T1 is there, so T1 wants to access the critical section for first time, so it will use the lock method, and it will increment the head count by 1. So it will indicate that the thread T1 has acquired the lock, and its the head count is 1. So and it will acquire the lock for some time, and it will again release the lock. So how it will release? It will release using the unlock method. So lock is there as unlock. So what unlock does? It decrements as its opposite to lock. It decrements the lock held count by 1, and the count reaches 0 and the resource is released. Remember here, the count should be 0 when the resource is released. Decrement lock held by held count and count reaches release. Lock, unlock, lock, unlock. So this can go so as to improve the overall throughput. After that is a matter lock interruptibility. Acquires lock until current thread is interrupted and returns the lock immediately if interrupted. Yeah, so basically it holds the lock if it's interrupted, and immediately returns if the lock is interrupted. It checks if the basically it checks the lock until the current thread is interrupted. Yeah, as I told, and another important method is getHoldCount. So it returns the number of holds on this lock by the current thread. Yeah, number of holds on this lock by the current thread, or 0 if the lock is not held by the current thread. GetHoldCount is important because it returns the number of hold on this lock by the current thread, and how many times the current thread has held the lock to returns the hold count. And if it's not held by the current thread, ultimately it will returns 0, and if it's returned 0, it will again means that any other thread might acquire the lock using the lock method. Yeah, there is also one important method called as try lock. So acquires the lock if it's not held by another thread and returns immediately the value true, setting the lock hold count to 1. Yeah, as I told you, it can acquire lock. So try lock is the method to check if the acquires the lock if it's not held by another thread, and returns immediately with the value true, setting the whole lock hold count to 1. So this scenario can arise even when the get hold count is 0. So ultimately when get hold count is 0 means current thread is not holding a lock. So using try lock you can acquire the lock on that thread, and it returns immediately with the value true, means, and setting the hold count to 1. Hold count is set to 1 and the value is set to true. After that we have isLock. Check if the lock is being currently held by any thread. So isLock checks if it's held by any thread using isLocked. So this video was all about to give an introduction on what is basically what do you mean by Reentrant lock. So what are the important methods in it, by definition what is basically interlock and how it differs from the traditional synchronization. So to give brief introduction and some important overview regarding the Reentrant lock concepts. So stay tuned for more. In the next video we'll see some more details. Do keep liking, subscribing, #TechieMit. Bye for now.